So I'm going to demonstrate a thing I've developed called significant terms, and it's something that I put into the Elasticsearch search engine, but now we have a JavaScript implementation. And what significant terms does is similar in concept to what cameras do when they focus in on the subject in an image. So the idea is that you can focus in selectively on the subject in an image, and cameras nowadays have quite smart AI features and things like that to do this kind of detection. So this is a statue of H.G. Wells, and it's able to focus in on that. So H.G. Wells is going to feature oddly enough later on, so we'll come back to that. But what we have is a capability in JavaScript to do the same thing but with text. So we can effectively apply a form of slider that will say zoom in on the significant words in a piece of text. Now, the sort of places you might have seen this before, if you look at things like Google Maps, when you go sort of looking around at various different things, I'm looking at campsites here. We have a whole bunch of reviews, so we've got 870 reviews that I could read to see if this is a good campsite or not. But one of the things it does is it highlights significant words or phrases from all of those 870 reviews compared to all the other ones. So this one, for example, has a pontoon. So if we click on that, then we've narrowed down the search results to show this rather lovely pontoon out in the middle of Lake Annecy. But we can apply the same approach in JavaScript to text content. So what I have in this demonstration here, in the first demonstration, is 600 or 700 news headlines about various different topics. And we have the ability here with a slider to organize them into clusters. So if you're familiar with the QRY codes demos that I've talked about before, we have a clustering capability to group these things based on similarity using vectors and things under the covers. But what's new here is the fact that each of these clusters that we've developed, of which there are several here, we've been able to process the text and come up with the significant terms or keywords that make this cluster different to this one. So in this one, we've got the keywords Keir and Starmer, which is put together into a phrase. So if I click, I can step through the documents in that cluster that mention Keir Starmer or perhaps the Labour Party. And that's what makes this cluster different to these clusters here. So these keywords appear much more in this set of results than they do in this one, which is talking about Trump and the ordering the National Guard into Washington, D.C., for example. So these are terms that haven't been pre-calculated. So maybe in the Google Maps example, some of these things might have been generated overnight for every single campsite or other business in Google Maps' databases. But here we've got something that's formed completely dynamically on the client in the form of arbitrary clusters, and we're able to generate this stuff on the client. So that's a pretty cool feature. In a similar vein, we have the ability to take search results, and rather than doing significant terms analysis using Elasticsearch on the server, we can now do this sort of stuff on the client potentially. So I have a random set of search results here relating to Trump and Putin and the Alaska summit, and consequently these are the significant terms found in these set of search results. Now, unlike my other demo, the cluster demo has a foreground and a background, which it uses for its comparisons, where each cluster is compared with all of the other clusters. So the foreground used in the calculation is the statistics of word use in this cluster, and the background is all the other clusters in the set. So you always need the idea of a foreground and a background, so the difference between what it is you're focusing in on and what you're trying to take away. So in this data set here, I'm working with a background which is very similar to what you might have in Elasticsearch. So the background is basically a set of documents, which is the whole set of documents from which these search results are drawn. And we can see the overlap between the background and the foreground. So we can see that the foreground is wholly contained within the background. It doesn't use a single word that's outside of this background vocabulary. Every single word is known. So consequently, you'd think this would be sort of state of the art. And if we were to use anything other than a complete superset, then we might have trouble identifying keywords. Well, you might think that, but actually it turns out that's not the case. So let's try another example here. We're going to use a different superset here, a different background. And this isn't guaranteed to be a complete superset. So it's a collection of recent news articles, and it doesn't entirely overlap. So it's from a similar time period, but there are certain things that appear in the search results, like anchorage, which just simply didn't appear in the background anywhere. So the difference between using all of the results and a similar domain-specific sample of data isn't that much. If you look at the significant terms when I make the switch here, Alaska Summit, Trump, Putin, Alaska Summit, Trump, Putin, Vladimir, blah, 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 doesn't change that much. Now, one of the things to notice is that actually anchorage was pulled out even though it's not in the vocabulary of this recent news data. And that might be surprising. In fact, if we try the third data set, that is a completely out-of-domain sample of data. It's basically a novel written in 1898 by, guess who, H.G. Wells. And if you look at the set of keywords that it's finding, it's just as good as the contemporary one or the superset. Now, the reason behind that, which we've shown, let's show the coverage here. So this is War of the Worlds here, the novel written in 1898. And this is our set of search results, which are to do with Trump and the Alaskan Summit. And you can see that there are a whole bunch of words that are in the search results which just do not exist in War of the Worlds. So Putin, Alaska, Trump, Ukraine, Zelensky, many other things also are not in War of the Worlds. Influencers, YouTube, helicopters, you name it. But it's still very good at highlighting significant terms. And that's largely down to the fact that it takes away the boring ones. So there's some words here about how backgrounds help score. So they either elevate words that they understand, so it looks at the documents and say, I know what explosion is, I see that in about 1 in every 10,000 documents. But if it sees it in 1 in every 100 documents in the foreground search results, it sees that that's a significant increase, and therefore it must be a set of documents talking about an explosion or a hurricane, for example. Conversely, rejected terms are things like the and of, boring words that it sees all the time, and it sees them just as frequently in the background data set as it does in the foreground data set, so it just rejects those. And the third category of terms is what I've called exposed. So these are words that are uncovered after you take away all the boring ones. And it might reveal things like the name of a missing person who's only just been identified and was hitherto never referenced in any news articles ever. So there's a surprising amount of documents that get matched or are exposed by War of the Worlds. So if you look at what War of the Worlds did when it found the top results that it matched, Zelensky was interesting because that was just exposed. It's a bit like going fishing, and rather than taking a different bit of bait or a lure to catch all these different type of fish that might be in the water, you just take away all the water. You drain the pond of all the boring stuff like the words the and of, etc., and then you're left with all these rare words at the bottom that you perhaps don't even understand or know anything about. Some of these words we did know about. So War of the Worlds, for example, has used the word meet or meeting, but it saw that in the Alaskan search results, the words meet and meeting were much more common than they were in everyday use. So the end result of all this is that a novel from 1898 is pretty effective at matching contemporary news articles, and that's a bit of a surprise, really. So the algorithms that I wrote for Elasticsearch use terabytes of leucine data to look up all these word frequencies in the background, and it's a distributed data set, and it's running in a server environment that's being used by many people, and we have limited amount of time to do anything particularly heavy in terms of analysis. And it's really overkill really for this job, because what we've discovered through the use of JavaScript here is that it is possible to do this stuff in the browser, and the quality of discoveries with a cheap policy of demoting the boring words, so the ones that were used in 1898 are still current today and still boring, and that's just as good as a very expensive policy of promoting interesting words based on a huge vocabulary on a distributed data store and everything else. So basically a tiny text file with the statistics of language use is all that you need to subtract and get significant keywords that are useful and can be used in guiding people through clarifying queries and rewriting their queries so they might click and then add these search terms to refine their queries and so on. So there's lots of potential applications for significant terms, query refinement, cluster labeling, trend spotting over time. And now we have a JavaScript implementation that we can use to do all this stuff in the client without having to burden our Elasticsearch or Solr or Opensearch servers with all of that number crunching.